Hey guys, so moving on for our equation that we saw previously for working out the fringe separation, which included a number of variables. Let's see where that actually comes from. Okay, so here we have in our diagram here, we've got our double slit over here, and we've got a separation of the slits of D. Okay, we've got a path difference here with two rays of light. All right, now the conditions that we must consider, the waves must be in phase, which is why we normally have a single slit when Young first did this. Obviously, nowadays we use things like lasers. It doesn't require us to have that same issue because the waves are already coherent. It allows this situation to exist where a whole number integer lambda is equal to d sine theta, and it's now going to be an equation where we observe the maxima rather than the minima. All right, so consider this situation over here. Now in this situation over here, on this side over here, we've got where the slits are. Over here we've got the screen, and what we have is a distance d between them. Okay, so we've got a number of variables being used over here. Here we've got the separation over here, and we've created our so-called TOA triangle as well, and we know that S over D is going to give us sine theta. Now let's put this together. If we go back to this equation over here, we also know that n lambda equals d sine theta. So what we can do is actually put the two equations together in this scenario. Now that allows us to get to a fantastic point, which is really cool. If we now have a look at these two equations, we can rearrange the equations to both equate to one another. If we now rearrange these, if you have a look over here, we now have the equation represented in the manner that we saw previously. Although we've left this integer in here, we don't actually have to keep it in there because we're going to take it as a value of 1. So we've got the lambda, we've got the distance to the screen, and then we can work out by using the slit separation the fringe separation. Okay guys, so nice straightforward deriving of equation there, hopefully nice and easy to follow. Any questions, email me as usual.